Okay, we talked about finding the probability using a standard normal distribution. So how do we go about finding the probability if we've got a normal distribution instead of a standard normal distribution? Okay, so one of the key properties for a normal curve is that the area under the curve in any region is the probability of a random variable falling within that region. Um, so how do we do this for a normal curve instead of a standard normal curve? Um, Basically, we convert it to a standard normal curve, and that's what we do. We convert our x values to z-scores and use the standard normal curve instead. Um, so we've got four types of basic problems. One, the probability that the random variable will be less than some value. Two, that it will be greater than some value. Three, that it will be between two values, or that it will be either less than one value or greater than another value. Uh, Temperature makes a great uh, example of this. So body temperatures of adults are normally distributed. We've got a standard deviation of, whoop, back here, get my highlighter here, sorry, or laser pointer. We've got a standard deviation of 0.73 and a mean of 98.6. So, type 1 problem. What is the probability of a healthy adult having a body temperature less than 96.9? Okay, so to write this mathematically, we use this form, P, probability that x is less than 96.9, right? So we need to first convert it to a standard score. So going the wrong direction and confusing myself, I'm sorry. All right, so to convert it to a standard score, we take our value, we subtract the mean off, we divide it by the standard deviation. So that's our mean, that's our standard deviation, that is the value we are interested in. We end up with a z-score of negative 2.33, meaning that 96.9 is 2.33 standard deviations below the mean. So in terms of graphs, we've converted this from 0.969 down here into negative 2.33. Our mean becomes 0, right? So we can now look this up in either the table or use the calculator or use the functions in Excel. However you want to do it, should all get the same number, which is 0.0099 approximately. I'm sure there's some rounding. Um, you can do this in one step in the TI 8384. I don't believe you can do it in one step in Excel. Oh, well, you can. You could embed the, yeah, you could do this in one step in Excel if you really wanted to. I would, unless you're very comfortable with Excel and functions, I would not do it in one step, but it can be done. Um, you can do it in one step in the calculator. It will do that conversion for you. All right, so now let's look at a type 2 problem. The probability that healthy adult body temperature is greater than 97.6. Okay, first we convert it to a standard score. Again, subtract off the mean and divide by the standard deviation. We end up with negative 1.37, so we've converted our 97.6 to negative 1.37, meaning we are 1.37 standard deviations below the mean. The negative tells us which side of the mean we're on, below it or above it. Okay, so now we need to find the area to the right of that. Again, we can use the tables, we can use the calculator, we can use Excel. Remember, for these problems where we're looking for something on the right, there's a couple ways to do it. We can either remember that the area under this whole curve is 1, and so we can subtract off the area to the left, which is what we would get from the table. We can subtract that off of 1, or we can take advantage of this being symmetric, because all normal curves are symmetric, and look at positive 1.37 instead, and that will give us the probability that something is to the left of positive 1.37 is the same as the probability that something will be to the right of negative 1.37. Same difference. So if we do that, we end up with 0.9147. Again, you can do this in one step in the calculator. And doing so actually eliminates some rounding error that happened when they rounded the z-score to negative 1.37. So you get a slightly different answer. This is one kind of gotcha with the tables. You've got to round the z-scores. Usually in math classes, we encourage people not to do any rounding until the very end of the problem to just avoid precisely this type of error. And the tables don't let you do that, so you lose a little bit of accuracy that way. With Excel, you'd carry all these values around through all the calculations as well. So doing this in Excel or the calculator helps avoid some of that rounding error. Okay, so now what is the probability of a healthy adult body temperature being between 98 and 99? That's what this is saying right here. So we need to convert both 98 and 99 to z-scores, again by subtracting off the mean and dividing by the standard deviation. Subtract off the mean, divide by the standard deviation. So we find that 98 is 0.82 standard deviations below the mean. Negative means we're below the mean. 99 is 0.55 standard deviations above the mean. So graphically, all we've really done is changed these numbers to these numbers. Everything else basically stays the same. All right. So remember, to do this, we can find the area to the left of 0.99 of 99, and then the area to the left of 98, and subtract the area to the left of 98 from the area to the left of 99. Using the z-scores in the table or anything, something like that. We can do this in the calculator in one step. We get 0.5027. There is again the alternate method of doing it in the calculator without doing that conversion to z-scores. And again, we get a slightly more accurate value by avoiding that round-off error. Doing this in Excel would also avoid the rounding error, because it can handle more digits in the z-score than the table can. Okay, so final one, type 4. Probability of a healthy adult having a body temperature less than 99.6 or greater than 100.6. So how common are those really outlier body temperatures? Right, so this is denoted this way: probability of x being body temperature in this case, being less than 99.6 or greater than 100.6. Again, we need to convert those temperatures to z-scores if we want to use the tables or the norm.s.dist function in Excel. So we take the value we're interested in, we subtract off the mean, we divide by the standard deviation, we get the number of standard deviations away from the mean. Oh, sorry, for some reason I was thinking 99.6 was down there, and I don't know why. It's apparently been a long day. Sorry. So we convert these to 1.37 standard deviations above the mean and 2.74 standard deviations above the mean, like so. Remember that the z-score is the distance from the mean in terms of standard deviations. So we need to find the sum of these two areas, this one and this one. So this one we can just look up in the table easily. This one we can either look up the negative 2.74 in the table, or we can do it by subtracting 2.74, the value from the table for 2.74 from 1. Either one works. We then add those two probabilities up, and that's our answer. Okay, so again, you can do this in the calculator. We cannot do this nicely in one step. You calculate the two probabilities and then add those. You can again do this without converting them in the calculator, without converting them to z-scores first. And it can be done in one step there. Good to know. Another way to look at it is, another similar problem is, what is the probability that somebody's body temperature is going to be more than 1 away from the mean? So again, more than 1 away from the mean, we're looking at those tails. They're symmetrically distributed this time as 1 away. So we're looking for 97.6 and below and 99.6 and above. So again, see, 97.6 and below, 99.6 and above. And that or, so we're looking at the areas on either side. Convert it to z-scores. Again, subtract off the mean, divide by the standard deviation. So we have plus or minus 1.37 standard deviations. Just as with the previous problem, you can, well, we can do this a little more simply. We can look up the one value and multiply by 2 because it's symmetric. That's probably the simplest way to do it. We can go through the exact same steps we went through for the last example, or we can just look it up for one side and multiply by 2. If we do that, we end up with 1.176. Excuse me. Again, we can do this in one step with the calculator. 0.1706. Okay. And eliminate some of the rounding error that comes from the z-score calculation being cut off as we need to for the tables, and we end up with a very slightly different number. Okay. There's the